All right, law of sines and cosines can be used in any triangle. Does not have to be a right triangle. Unlike SOHCAHTOA, it's got to be a right triangle if you want to use that. Law of sines and cosines can be used in any type of triangle. Law of sines says the following. If you take a side, let's say side A, and put it over the sine of the angle across from it, that is in the same ratio as another side and the sine of the angle across from it. Okay, that is law of sines. Convenient, I like it a lot because it can be used on any triangle. Okay, you're not forced to make a right triangle. Law of cosines, not too much, but it is available if you want to use it. Law of cosines, you need to know something about all three sides. Whether that's two given and a missing or all three sides, you need to know something about all three sides. And here's what it says. A squared equals b squared plus c squared minus 2bc cosine A. And just to remind you what A, B, and C are. A, this side you put first in law of cosines is always the side across from the given angle. Okay, and then angle A is the given angle. B and C are the other two sides. Okay, law of sines and cosines, once again, any type of triangle that can be used. I would definitely be comfortable using law of sines going into this exam Tuesday. Now, I will let you know, are these required? No, this was kind of like an extra topic I taught you guys. But I think this is extremely, extremely valuable law of sines, especially if you're not a big SOHCAHTOA fan. Especially if you're not a SOHCAHTOA fan. All right, very valuable. What else you got for me here? Let's shoot them, Evan. I'm ready. Got it all up here. Which exam? June 2017. Which number, Evan? A plane intersects a hexagonal prism. Am I on the right one or no? June 2017. I'm on January. Perfect. Let's try this again with June. Okay, 23. Little circle question. What? June 16. Okay, how about I actually sit down and look at this now? Okay, June 2017 geometry, PDF, got it. Let's see if I can get it now. 23, this bad boy? Yeah, all right. All right. So it looks like we have got a half cylinder on top, rectangular prism on the bottom. How much metal to the nearest cubic inch will the railing contain? All right, first thing, I don't see a magic word of volume or surface area here. Anybody know the phrase up here that's going to key me in to find surface area or volume? What do you got for me there, Ethan? Cubic inch tells me what I'm going to find. What should I find then, Ethan? I should find the volume, yes. So let's cut this out. And this is a good question, because I'll freely admit there was one part of this question that I had a tough time with, and it took me about 2 or 3 minutes to finally figure out. So we got the volume of a half cylinder. And then we're going to do the volume of the prism and add those two bad boys together. All right. Volume of a cylinder, it's on your formula sheet. 1/2 pi r squared height. It's usually pi r squared times the height, but I'm putting in the 1/2 because it's half a cylinder. Everyone's all good. Okay. Here's where I had a little trouble. I was like, what the heck's the radius? Okay. What the heck's the, because here's your half cylinder right here. And I was like, what the heck's the radius? I assumed, oh, probably just cut 2.5 in half and you get 1.25, but that was just a guess, and I didn't have any mathematical proof to tell you guys until I found, oh, hold on. If that's 2.5, isn't that whole thing also 2.5 inches? And what's that acting as? That's my diameter. Okay, so if I wanted the radius, then I would cut that in half, and that's where the 1.25 would occur. Good. And I'm still not done yet. There's still one other catch here. I don't know if anybody sees it, if this is your first time doing the problem. The height of the cylinder from base to base. How far is it from that half circle to that half circle? 27 feet. That's great, but these are in inches, and my answer has to be in inches. So I can't plug 27 in. These little things I know are going to catch up to you. I know it. These little things. So now, before I even started, I needed to convert 27 into inches before I plugged it into any formula. So 27 times 12, whatever that happened to be, I'll just plop it in right there, 27 times 12. Good, Evan? And then we go to the prism. Prism's a little easier. You got 2.5. Then you're going to plug in the conversion of inches and feet. And then I'm going to do 2.5 feet. Okay? And then I'm going to add them together. So two tricky, yep.
You can't add them together because
why not?
That's doing the volume for that whole thing. You'd have to subtract, right?
Yeah, you'd have to do.
Why would I subtract?
No, one of the 2.5.
You don't know the height for the prism.
Oh, sorry. That should be 1.25.
Wait, but how do you know that that's directly in that?
Because here you go. Ready? This was the diameter of 2.5. That means the radius from this here up is also 1.25, which means the remaining part, the height of the prism, also has to be 1.25. So it should be 1.25 for the height. Okay? Good question, Evan. Concepts, other questions? Yep. Same exam? Okay, 26, everybody. Okay, this is a formula we're going to come in knowing. It's also on your cold hard fact sheet. Area of a sector. I'll review both formulas right now. Area of a sector, there's two formulas, one in degrees and one in radians. Personally, and just knowing you guys for 40 weeks, I think it's good to know both so you don't have to worry about converting degrees and radians on your own, because I don't know how comfortable any of you are there, even though it's on your formula sheet. So in degrees, area of a sector is the measure of the arc over 360 times pi r squared. If it's in radians, I'm going to use the formula 1/2 r squared theta. Theta is the angle in radians. Which one do they give me here, degrees or radians? Degrees, so I'm going to use the first one, which is 40 degrees over 360 times pi. They give me a radius of 4.5 squared. Are we comfortable leaving it in terms of pi? I still have a little like piece of me that's worried. Leave it in terms of pi. So everyone's doing 40 over 360 times 4.5 squared, leaving the pi totally out of your calculator screen. And then whatever number you get there, which I believe I've done this a couple times, 2.25, then I attach the pi with it. Or if you want to leave it as a fraction, 9 pi over 4. Yep, go ahead.
Should we memorize?
It's pretty worthy, yeah. Yep. That and the arc length formulas. Arc length, let's just go over it while we're here. You also have 2 formulas for arc length. If it's in degrees, very similar to this one, right? Measure over 360, but I don't multiply by pi r squared. Anybody remember? Pi d, the circumference, yep. And then if it's in radians, anybody remember that one? So I call it SOR. S equals theta r. What's S again? That's my arc length. And again, this is my angle in radians. Both of those should be on your formula sheet as well. They may not have SOR on your cold hard fact sheet. They may have theta equals S over R. It's still the same thing. Okay? We're getting down to the nitty gritty here, huh? Anything else here? Or should I make like a big speech about how happy and how great this year was, first period? And yeah, it was great. It was real. It was real. It was good. But it wasn't real good. No? Too harsh? You just started talking like 3 weeks ago, Carolyn, so calm it down, yeah. Yep. Madeline, sure. Hi. Hills and Sass? Sure. I believe, let me just, if you guys go to the January 2018 exam, I don't know if anybody has it on them, but January 2018, I believe there was a Hills and Sass question. And I believe that's a good way to finish up the year right here. January 2018, little Hills and Sass. There it is. There it is. Number 23, Hills and Sass, January 2018. Let's end this on a good note. I didn't even read the problem. I just looked at the diagram. How can the diagram automatically key you into, hey, this must be a Hills-Sass? What's got to be the original triangle? A right triangle, and then what's got to be drawn to the hypotenuse? An altitude. Done. It's got to be a Hills and Sass. All right, so let's see. We're looking for the length of BC. What's BC? What do I classify as far as Hills and Sass go? What's BC? That's a leg. What's BD? Altitude. CD? Segment. How about CA? Hypotenuse. So is the altitude involved at all? Is it labeled or do I have to find it? No. So there goes Sass. So I'm going to end up using Hills here. H for hypotenuse. How long is it? 12 over the leg. You got 2 to choose from, but more importantly to us is X. What do you know about the 2 legs in Hills? They're both the same, right? And now which segment do I use? The one adjacent to the leg I put into the proportion. So in this case, I'll put in CD, not labeled though. 4, yep, 12 minus 8. And then we're on our way. X squared equals 48. Break down 48. Anybody know off the top of their head, biggest perfect square? 16 times 3. So it end up being 4 radical 3. Wow, that's a wrap. Can't wait to take those tests. If I don't see you at the review sessions, good luck on your exams. Hopefully I will. Yes. I did not check it because you guys had the answers and everything, so. Yep.